Good morning everyone. So in this video we are going to see about a combine harvester and its components and working. What is combine harvester? It is a machine which performs the function of a reaper, thresher and winnower. Functions: cutting the standing crops, feeding the cut crops into the threshing unit, threshing the crops, cleaning the grains it from straw, collecting the grains in a container. Components: header, elevator canvas, threshing drum, chaffer, sieve, tailing auger, reel, feeder canvas, concave, grain sieve, grain elevator, cutter bar, feeding drum, fan, grain auger, grain container. Header is used to cut and gather the crops and deliver it to the threshing unit. The straw is pushed back on the platform by the reel. Small combines use scoop type header, while large combines use T type header. Harvesting is done by a cutting unit which uses the cutter bore similar to that of the mower. The knife has got serrated edge to prevent the straw from slipping while in operation. There is a suitable cutting platform which is provided with a reel and canvas. Reel is made up of wooden slate which helps in feeding the crop to the cutting platform. The reel gets to the power through suitable gears and shaft. The reel revolves in front of the cutter bar while working in the field. The unthreshed grains pass through the tailing auger and go for rethreshing. The clean grain passes through the grain elevator and finally goes to the packing unit. Grains are collected in the hopper provided at suitable place. The fan is adjusted such that the shaft, etc., blow off the rear side of the machine. The size of the combine is indicated by width of cut it covers in the field. Advantages of combine harvester: it serves the cost of harvesting and threshing the crops. It reduces the labor requirement of the field. The grains can be obtained easily from the crop and thus the risk of fire, rain, other hazards are minimized. It cleans the field earlier, which permits easy dry weather farming. As the grain come to the hand earlier, there is very possibility to get good profit in the market. Disadvantage: higher initial cost and unadaptable for mixed farming. Combine losses: there are different types of grain losses in the field before and during combining of crops. Moisture content at the time of harvesting affect the grain losses. At low moisture content, grain losses or pre-harvest shattering loss, cutter bar loss, and more breakage of grain. At low moisture, the straw is broken finely by the cylinder and more material flow to the sieve, resulting into separation problem. There is a risk of natural hazard like rain and hailstorm, which also lead to logging of crops. Due to delay in harvesting, more weed growth take place that cause choking of combine. At high moisture content, grains are badly damaged by the cylinder action. The threshing is poor and good cleaning is also a problem. This leads to a higher cylinder loss and low cleaning efficiency. The grains get sucked to moisture straw and are carried away with the straw and chaff. There might be choking problem at different stages in the combine due to high moisture content. As per this, the combine losses should be maximum 2.5 for wheat, paddy and gram and 4% for soybean. Various combine loss section in combine harvester. Pre-harvest loss. It is determined at minimum of 3 places randomly selected in the field where combine harvest is to be operated. The sample should be collected from the area having 1 meter length in direction of travel and full or half width of cutter bore of machine depending upon its size. All the loose grains, complete and incomplete earhead fallen in the marked area have to be picked up manually without vibrating the plant before the machine is to be operated. Header loss. It is determined on those portions of ground which are protected from combine afflux by the use of rolls of cloth. The loose grains or complete and incomplete earheads fall on the marked area where pre-harvested losses were determined. Shall be collected manually. This gives the header loss. Header loss is equal to grain collected from 1 meter square area after harvest minus grain collected from the same area before harvest by gross yield. Rack or shoe loss. For determining the rack and shoe loss, the straw and chaff affluent is collected separately. To collect these, 2 rolls of cloth 30 meter in length and 1.5 times the width of the straw or chaff outlay is suspended on specially attached fitting beneath the rear of the machine. As the sheet of the cloth unroll, one sheet retains the flex from the straw walker and the other from sieve for 20 meter run length. Unrolling separation starts 5 meter in advance and terminates 5 meter ahead of the end point. Rack loss is equal to free grain collected from straw rack sample divided by gross yield into 100. Sieve loss is equal to free grain collected from the sieve sample divided by gross yield into 100. Grain crackage. It is determined from the sample taken from grain tank. Only visible damaged grains are separated and expressed in percentage of sample taken. Grain crackage is equal to damaged grain wholly or partially collected from sample divided by gross yield into 100. These are some of the formulas for determining the losses. Expected range of losses. Losses with the best combine adjustments will vary greatly depending upon the types, variety, and the condition of the crop. Total loss in clean crop of wheat, oat, and barley will vary from 1 to 4 percentage of total yield. Under good harvesting condition, the total losses should not be more than 1.5 percentage. Cutter bore loss may be 0.5 to 2%. Cylinder losses 0.5 to 1%. Rack losses 0.2 to 0.4%. Shoe loss 0.2 to 0.4%. The losses could be minimized by running the combine at proper adjustments. Cutting and conveying. The height of cut can be adjusted from 5 cm to 75 cm in most of the combine. The rate of feeding can be adjusted by manipulating height of cut and forward speed of machine. Forward speed of 2.5 to 4.5 km per hour for standing crop and 1 to 1.5 km per hour for logged crops has been recommended by ISI. The speed of cutter bore varies from 400 to 500 rpm. Reel adjustment. The horizontal positioning should be such that reel blades have a distance of 5 to 100 mm in front of the cutter bore. The optimum value of reel index should be 1.10 to 1.25. So in this video we have seen about the combine harvester components, its working and the losses in combine harvester. Thank you.